Good afternoon, everyone. Thank you so much for joining us today for this session. Just to make sure folks are in the right place, this is BRK3300, actually 3300R. So I think I see all new faces, but just in case, if anyone joined us at noon for the other BRK3300 session, this one is a repeat. We're more than happy to have you again, of course, but just in case, wanted to let folks know. My name is Andrew Chen. I'm a PM with Azure Storage and the lead PM responsible for Azure NetApp Files. And I'm joined today by a couple co-speakers, Prashant Desai from NetApp, who's my counterpart and partner in developing this service together jointly with NetApp, and we'll explain a little bit more on this later. And later in the talk, we'll also have one of our joint mutual partners join us on stage and share some of their perspectives in going through the preview of this service. Maybe before we dive in, quick poll. So hopefully everyone's having a good conference so far. Content's been useful, helpful. Okay, how many folks here are like IT pro or storage background? Could we do show of hands? Okay, great. And then how many of you are NetApp users or already existing NetApp users? Okay, great. And then to be unspecified, other storage array users? Okay, excellent, thank you. So hopefully this session will be very useful. In terms of what we're hoping to deliver to make your time worthwhile, it's pretty simple. We want to do a comprehensive walkthrough of Azure NetApp Files end to end, sort of explain all of the core concepts of the service. We'll peel back the covers a little bit and show some key information about the architecture, how it was built, and some of the considerations around deployment. Give some indications to some of the things we're thinking about doing directionally. Basically make sure you understand all of the product capabilities and considerations. We'll also talk about use cases so that you can understand, okay, here are either needs I've had for file storage and cloud or things that I want to do, things that I can do with it, and then hopefully get you, started on your journey to being able to deploy and consume this service. And then to that end, our agenda is fairly simple. We'll basically spend time on a walk through all of those different elements, and to keep it interesting, we'll also do some demos and walkthroughs of the experience along the way to sort of illustrate the concepts that we're talking about. And then we'll be joined by a partner for some sort of third-party perspective on their impressions of the service so far. And then finally, we'll have Q&A, share some resources that you can use, and some follow-ups. All right, so we'll dive right into it. Part of starting, I think one of the questions we sometimes have to answer up front is even, why file workloads in the cloud, or do file workloads, file protocols have a place in the cloud? After all, NFS is what, like 30 years old. But let's sort of take a look at some of the factors around that. One is that although the cloud journey is now pretty far underway and is maturing and accelerating with each passing day, fact of the matter is still the majority of enterprise and mission critical workloads continue to be on premises, and that's dominantly because a lot of the infrastructures in those cases have capabilities that haven't yet been present in the cloud to service those workloads. Then, of enterprise workloads that are still on-premise, that are using external storage, about half of them are using file protocols today. And we don't really see that changing because the third major factor is that this is actually still a growth space, right? So file storage is still continuing to grow at a pretty healthy CAGR that I think any of us for our business wouldn't mind having, and is still going to reach a pretty eye-watering number of exabytes by the end of the decade. So the demand is still there, and the feedback that we've gotten from customers, partners, and prospects clearly reinforces that. Just this morning, I actually was talking to a customer who's needs file services in the cloud and has basically done so by standing up sort of their own IaaS file server or virtual appliance. So I don't know how many folks have had to do that. Probably fewer folks enjoy it, and so they said, look, I'm having to do this. I'm having problems with the capabilities in terms of getting the right level of performance, HA, scalability, plus all of the administrative overhead that I had to do on premise. I'm basically doing this in the cloud. Please make it go away, but please make it go away without compromises, right? So I need a cloud solution that isn't going to force me into having trade-offs around performance and performance scale. reliability, right? Particularly if you deploy VM-based solutions, getting HA and getting that redundancy can be problematic in terms of how do you do something like an HA pair or a cluster. And then finally, the last thing is, of course, delivering. Just a plain file share is non-trivial, but not that hard to do. But the biggest thing is then, do you have the data management services and capabilities and protection around it that really make it enterprise grade? And so it was with all of the, sort of these requirements and mission in mind that we set out to build Azure NetApp Files. So it is a fully managed service. And spent a lot more time on what that means. But okay, so if there was a short list of only 2 or 3 takeaways that you leave this session with, the number one sort of thing that we want to clear up or make sure that everybody understands is that this is a first-party Microsoft service. So to be absolutely clear, Microsoft Azure and NetApp are collaborating, and we've entered into a long-term strategic agreement and partnership in order to build and support this service together. But it is, at the end of the day, from a transaction, from a consumption, and from a support standpoint, a Microsoft service to ensure that there's basically one single throat to choke and sort of one very consistent and easy experience for consuming that service. So for example, as a customer, if you are a Microsoft Azure customer and you have an enterprise agreement or you have a commit, the consumption of this service counts against that commit. The way this bills is you will consume it same as any other Azure resource, and it will just show up as a line item on your Azure billing. There's no separate contract that you have to do. There's no other SKU. It's not like you buy one piece from Microsoft and you've got to go get a license from NetApp. It is turnkey, and you can buy it at will from Microsoft Azure, same as any other Azure storage service, just like Azure Blobs or VMs or Compute or anything of that sort. And the same is true for support. So whatever support level agreement that you have or entitlement that you have for Azure for your other services is the same manner in which your consumption and usage of Azure NetApp Files is covered. Microsoft takes first call support and is responsible for managing your end-to-end support experience. If there's escalation or additional engineering support needed on the back end in cooperation with NetApp, we have all of the process integration and engineering resources and support to ensure that, but we also want to make sure that that's not part of your customer experience should you, and of course we're doing everything to make sure that you don't, but should you have any issues in consumption of the service, you have one party that is accountable end to end for all of that. So again, if you're an EA customer, you can just go ahead and use your EA. If you're a CSP customer, that's fine too. And if you're a CSP partner, you can also transact and make Azure NetApp Files part of your practice, same as any other Azure CSP service. So end to end, and then finally, if you're a Microsoft rep, Microsoft sales reps are fully compensated on the service, so they should be more than happy to assist you as customers in this, as well as the NetApp field also being fully engaged and compensated to help drive Azure NetApp Files. So from both companies, you'll have all of the necessary sort of field and engagement support in deploying Azure NetApp Files in your environment. So with that in mind, I'd like to turn this over to Prashant, who can talk a little bit also about the service.
Yeah, and I'll start with, what a journey it's been. From an engineering perspective, the last year and a half, joined Microsoft NetApp engineering teams. We've been working together to ensure that ONTAP, with all its goodness, is available as a simple managed cloud service without any compromise. And it's had countless number of hackathons in Redmond. Network engineering team, ONTAP engineering, control plane, to ensure the level of integration that Andrew mentioned is available in the service. And again, the singular vision for the joint engineering teams has been, there are no compromises. ONTAP, with all its high availability capabilities, data durability, performance, low latency, high throughput, all of the things that you get on-prem, and the data management capabilities, flex clones, snapshots, data protection, things that you get on-prem, we want to give all of those to you in Azure without any compromise. That has been the single most, the only goal for us on the engineering and the product side. The vision extends beyond just ONTAP. The two companies strategically are tied in the hybrid cloud vision and the strategy to make sure you can get the best of a hybrid cloud. You can put applications, workloads in Azure, And if you want some in the on-prem, you can seamlessly move workloads and data across. So you'll see more announcements and more capabilities that allow you to do that. And then last but not the least, security. We understand as you go to the public cloud into Azure, security is the top of your mind. You are leveraging Azure best practices, the best Azure has to offer, and things that are baked into ONTAP to ensure that from a control plane, you're leveraging Azure, ARM architecture, IAM policies, all the things that Azure has built in. From a data plane perspective, ONTAP has FIPS compliant NV volume encryption. Leveraging that, secure multi-tenancy. We'll talk about a lot of capabilities that are baked into ONTAP. Also enterprise-grade security architectures, LDAP, Kerberos, all of those things that are baked into ONTAP will be available, and some of them are already in the preview. The service is in preview right now in the US East location, and if you're interested, you can go to azure.com. We have a landing page for Azure NetApp Files. You can sign up for there, and then we'll be expanding into additional regions, US West 2 region, end of October, and as we go out, a global rollout. Kind of clicking down into what exactly the service can do for you. And I go back, ONTAP's been used for 25 years by 300,000 customers across any vertical you can think of. Finance, oil and gas, technology, banks, name it, and ONTAP's cornerstone of their data and storage management workloads. So the use case and applicability for this service is extremely wide. And again, the design point for us has been to make sure that you can service primary workloads in Azure, not backup, not DR, primary workloads without compromise you can run in Azure. The scenarios could be as simple as if you're working on a migration strategy. If there is a subset of workloads on-prem that you want to move in Azure, or if you want to consolidate entire data centers and move them, all the workloads into Azure. If you have any Linux open source Unix footprint, it's a no-brainer. You can now move those workloads in a jiffy, very simply, very fast into Azure without having to worry about how to re-architect them, without having to worry about, am I going to get the performance, am I going to get the IOPS, and data management. We understand for enterprise customers, it's not about just speeds and feeds and latency. It's about how do you manage your data? How do I support my DevOps? Can I snapshot? Can I recover? Is it integrated? If I have an Oracle app, can I get application consistent snapshots? If I'm running SQL Server, can I get application consistent snapshots? If I have Oracle, again, another example, and you have a database with 1 million objects, you see performance issues, right? It's common. So, well, I need to play with the indexes. Do you want to create a copy of your database? No, you want to create a clone of it. That's how you do on-prem. And there is no reason why you should not expect the same in the public cloud. Take your database, create a clone, create tens of clones, hundreds of clones, and get your engineers to work on it, get CI/CD, continuous integration, continuous delivery out in the public cloud by leveraging the data management capabilities. And I would say it extends beyond traditional workloads. We talk about AI and machine learning. And one of the things that comes forth is relearning. You have classifiers and you have labeled data sets, and you have to keep relearning them. You have to keep retraining them. Well, do you want to make copies of that? Well, you leverage clones, and you can create hundreds of clones, read-writable clones. You can have all your engineers work upon it. So you can start with on-prem workloads. If you're building brand new applications in the cloud, we understand you go to the cloud to build simple, scalable, performant applications. Well, if you want to scale, you really want to scale out and scale up. Scale out is one of the reasons why you go to public cloud. How are you going to be scaling out without highly performant shared storage? That is what this service brings to you. Opens up completely new dimensions for building simple, high-performant applications in the cloud. The other, I mentioned machine learning. This is an Azure service. We're going to be leveraging connection points, building bridges with other Azure services. If you want to use the service with HD Insight, we have a connector for it. If you want to create a microservice architecture, and we understand storage, persistent storage is a big problem for it, we'll have a connector where you can use Azure NetApp Files to provide storage for your containers environment. So the vision starts with what you have right now on-prem, but we're looking at a whole set of workloads which are next-gen, born in the cloud. And before we exit this slide onto the next one, I'd like to leave with a simple message. While the service is powerful, there's a lot you can do with it. Start with something simple. You have home directories, file shares, bring them on. Last couple of days at the booth, we had over a dozen customers come talk about NAS sprawl, hundreds of terabytes of just file shares spread all across their data center. Move them over to Azure NetApp Files. You can move enterprise applications, databases, all of that is possible, but if you want, you can start with something small. And then we talked about integration, being a native service. I think we can start looking at this chart to really internalize what it means. Azure NetApp Files is an Azure resource. It's an Azure service. The hierarchy that's shown here really starts with the Azure subscription. As long as you have an Azure subscription, you can use this service. Underneath the Azure subscription, you can go and create an Azure NetApp account. It's similar to an Azure storage account, the same purpose. It's a different namespace. You can assign a region to it, and then you can create pools of capacity. The service is delivered today in the, as a provision capacity model. So you buy a pool of capacity, and then you can carve it out into any number of volumes. The capacity pool that you buy is built on an hourly basis, same as any other Azure resource. So if you spin up a pool of capacity for a couple of hours, you only get billed for a couple of hours. The pool then can be carved out into hundreds of volumes. You pick the size, and we allocate to it capacity and also performance. We'll talk about performance in the next slide, but we'll allocate performance on the volume that is in line with the capacity that you assign to it. The thing that users have to remember is the sum total of allocated capacity across volumes. It has to add up to your total pool size. So if you have a pool size of 4, the sum total of capacity across your volumes has to add up to 4. Now,
one thing that just occurred to me is in this example, we are using 4, but by no means is the service limit 4.
It's a great point. Underneath a storage account, you can have hundreds of terabytes, petabytes of capacity. Things that you would need an entire team to manage on-prem, you can get done programmatically with the thing. You don't even need a person. It's all done programmatically and through the portal. This thing scales to petabytes. A single volume can be as small as 100 GB. It can grow to as large as 100 terabytes. And your pool can be hundreds of terabytes. And across multiple pools, you can have petabytes of capacity in management. Now, when you configure a pool, one of the attributes you have to assign to it is the performance level. And as we look on-prem, we know all workloads are not built the same way. There are workloads that need SSD class performance, very high throughput, very high IOPS, low latency. And then there are workloads, home directories we talked about web pages, static content, where you don't need the same class of performance. And we understand users have a different willingness to pay for the different value a workload gives to it. With that in mind, we have 3 service levels designed, so you can pick the right one for your workload. In the preview today, you can come and experience the premium service level, which gives you per terabyte of capacity that you assign to a volume. Per terabyte of quota, you can get up to 64 megabytes of throughput. And if you take a 16K block size as an example, you can get 4K IOPS from it. If you had an application that was 4K blocks, you would actually get 4 times that IOPS. The service is, the QoS policies applied on the service are based on a throughput level. It doesn't care what block size you use, you get that throughput. The premium service level is great for business critical applications, databases, analytics. In and around GA will deliver an additional higher level performance extreme, which is likely going to be 2x the throughput you get from a premium service level. And then at the same time, we'll also enable the standard service level, which is lower in throughput And it's great for workloads that did not require as much throughput or IOPS.
This is really consistent with how we've sort of managed product offerings in the rest of Azure Storage, right? Is you have a product and you want to have a consistent experience, but you want to have different tiers with different sort of price, performance, capacity combinations so that you can choose the right tier for the application and workload it need. And in a very similar principle, we've created the offerings here in Azure NetApp Files.
And the beauty of it, the flexibility doesn't end there. Through the portal, through the API, you can come and you can change, you can resize the volume and you can get more throughput. So let's say you are in a business which is seasonal and you need to scale out in the months of high demand, or you can increase the volume size and you double the quota and you get double the throughput out of it. Not only that, you can, as we introduce more service levels, you can flexibly go across tiers. Again, this can be done through the portal or programmatically through the API. It's unmatched flexibility. It's unparalleled, unrivaled in the cloud. Just to give you a feel for what kind of performance you should expect. This is, and we'll have more data to share and we'll publish it as we lead up to the GA of the service. But this is a sample that is from VD-Bench. We use VD-Bench to test against a 10 terabyte volume, a small 10 terabyte volume. We use VD-Bench, and you see the results here. It starts out at close to 600 microsecond latency, and you can drive for a 10 terabyte volume at 64 megabytes per second. The max you can get out of it is 640 megabytes per second, which is close to 5.2 gigabits per second. You can get all of it under a millisecond latency. And then you see the QoS policy kicking in up here, right? As you hit your 10 terabyte, 640 megabytes per second throughput limit, you can see QoS kicking in. And that's something important to understand. The QoS policy also protects you and your volume and your workloads from noisy neighbor. We get that asked many, many times. Any other volume you have in your own account or any other tenant's volume cannot impact the throughput or performance you can get from your volume because we have configured each volume with its own QoS policies. And if we kind of take this example forward, if you had a 20 terabyte volume, you would actually get close to 10 gigabits per second throughput from that volume. You can fill up a 10 gigi pipe. A single volume can fill up a 10 gigi pipe. To kind of round this off, I'll work through an example here where the users bought a 4 terabyte capacity pool. It could be 100 terabyte, it could be 500 terabyte. We'll work with a simple number here, 4 terabyte. You get billed on that 4 terabyte pool of capacity. And that billing is fractional hourly, so if you create a pool and you delete it after 2 hours, you get only billed for 2 hours, not for the whole month. Take that 4 terabyte capacity and you can carve it out whichever way you want. We have 3 volumes configured here, 2 terabyte, 200 GB, 1 terabyte, and you can see the QoS is configured based on the size of the volume. The 2 terabyte volume has 128 megabytes QoS provision. And then you have additional capacity that you can use to resize the volume or create more volumes. As usage grows, it has written to it, you can see the active file system size grows. That's the blue bar here. And if you take snapshots, snapshots will only use incremental fractional space based on how much the snapshots incremental usage is for the snaps. An important point to note here is the active file systems usage we show here is based on logical capacity. That is not block capacity, that's not raw disk capacity. That's the amount of data you write to the file system. Then an important thing to note here is, while I mentioned earlier that the sum total of capacity cannot exceed the pool, in the implementation, the number one goal for us is to avoid data corruption. We do not want data loss, we don't want data corruption, we'll never reject a write. So let's take the middle volume and let's say your usage grows beyond the 200 GB size. What happens? If you have a write, we'll honor it, we'll continue writing to it. You can configure through the portal or API threshold crossing alerts, so you'll be alerted on overage scenarios, but a write won't be rejected. The alert is to make sure that you can come and you can either resize the volume, and if you're running out of pool capacity, you would have to resize the pool. The whole idea is never reject a write. We don't want data corruption. Another detailed behavior to keep a note is when you are in an overage scenario, let's say the middle volume where you are in overage, your volume is 200 GB, but you've written 400 GB of data to it. We let you grow, but the QoS on that volume is configured based on 200 GB. So it's in your interest, as soon as you get an alert, come back and resize the volume so your QoS policy is in line with the data that you've written to the volume. That's one takeaway. I think with that, let's go a little bit into architecture.
Yeah, so we'll peel back the covers a little and look under the hood how this works. And over the next few slides, we'll go through a couple different angles of this and hopefully also build up some of the core components of the experience. First thing I want to talk about, if anybody had a chance to see the storage mega session yesterday and heard Jeffrey Snover's talk about security, was anybody there? So he does this really great narrative about how much effort and investment we put into securing Azure. So that's hiring the best talent, the best security experts around the world, constantly trying to break it and intrude into our own service ourselves, and being really, really obsessive about pretty much any element of security. And that means scanning any bit of code that gets deployed all the way down to the firmware, everything end to end. If you think about anybody like a human who has to interact with any element of the service sort of administratively or infrastructurally, many layers of security, right? So we have core concepts like just in time and just enough administrative, which basically means that nobody has anything except the bare minimum privileges for the bare minimum amount of time that's needed to do any critical transaction. We have secure access workstations that are specially hardened machines that can only be used for certain type of access. And all of that framework also applies to everything that we do in the service and how it's built. So again, one of the other key takeaways, hopefully, from this is that everything here is done very, very Azure consistently, and that includes all of the security and protection around making sure that this is a very hardened surface. So in this illustration, I'm going to go through blue arrows is control plane, purple is data plane. Let's kind of go through the sequence of what happens. In this case, the entry point is through the Azure portal. We'll talk a little bit more about other potential endpoints on the next slide. And as per typical, then it goes to the ARM gateway, and then it interacts with a brand new resource provider that was developed for this service, so the ANF resource provider, and that sort of has some of the typical functions of an Azure resource provider. So it interacts sort of with a couple main core components. The first one is a new orchestration engine, the ANF service delivery layer. And by the way, that delivery layer and the resource provider are hosted in Azure resources and sort of built to Azure best practices in terms of using things like scale sets and scalable VM instances. That service delivery engine serves a couple functions. One is it's basically the virtual storage administrator. So if you think about all of the administrative tasks you would have to do in sort of managing a filer, it does all of those in terms of, okay, how does it allocate the actual disks? How does it create aggregates? How does it assign tenancies? How does it handle the management of lifts and IP spaces and routing? And not just for one filer or one cluster, but basically an entire fleet. And we'll talk about that more. So then there's all of the inventory management and what's going on with tenancies and how they've been placed on the actual physical assets, and keeping all of that straight and also keeping the health of the service intact. So then it does things like billing, it does telemetry, metrics both from a supportability standpoint as well as things that you would be able to view sort of administratively in the console. Then the resource provider is also sort of talking sideways, which is, again, sort of typical for Azure services, where there's sort of orchestration of different Azure components required. Its primary partner in this is the Azure Network Resource Provider, which then talks to its regional resource management frameworks. And basically then what the two of these things are doing jointly is all of the end-to-end work to deploy an experience for you. So if you think from an administrator standpoint, well, shoot, if you were really just trying to do this from scratch, like you literally just had your PS or your partner deliver an Azure array in your data center completely from scratch, I mean, this process could take days or weeks. But even if you have something up and running, it can often take a fair bit of time to deploy storage for a new user. And these things are autonomously doing it in a matter of mere minutes, as you will see later on. But basically what happens is you get a tenancy. All of the work that's necessary from a switching standpoint to move it physically from there into your Azure VNet so that you can then mount the volumes and consume them is all done autonomously through this framework.
Shortcuts we took in delivering this service. It follows exactly the same architecture, ARM architecture, resource provider that would be taken for any Azure native service. And the beauty of the interaction that Andrew described between Azure NetApp Resource Provider and Azure Network Resource Provider is not only you get great performance, low throughput, we're plugged into Azure's SDN stack, but this architecture is extensible. In the future, we can plug into Databox or any other Azure native service. This is
the Insights, other Azure PaaS services or other Azure services. And so with that, programmatic deployment, right? So again, the RP is fully ARM consistent. So from a security standpoint, in terms of identity management, RBAC, the ability to sort of create roles or delegate users to access control plane functions, it is entirely consistent. The blade looks identical to any other Azure resource, and it basically uses that same framework. And then you have the same typical methods of access, right? So the portal is one way of doing so, but you can also use REST API. We will be progressively rolling out SDKs to enable sort of ease of use in working against the service programmatically. We will also be offering support for both Azure CLI and PowerShell. So whatever forms of scripting or other automation you want to use will be accessible and available for this service. And then, of course, if you're orchestrating deployments across many Azure resources or things that are sort of complex that you want to do repeatedly, also the ability to create ARM templates and deploy them through ARM templates, sort of as that little snippet there shows. And then what that allows you to do is basically any sort of standard CRUD or control plane operations against sort of the key objects of the service that Prashant outlined, right? So you can interact with and administer account pools and volumes. You'll have the ability to query and get information on your mount target. You'll be able to take snapshots, right? So again, there's an API for a snapshot call. So if you want to orchestrate something where you need some sort of app or state consistent snapshot, you will be able to do that through API. You can also set and control export policy, which we'll talk a little bit more about in a bit. One thing that is worth mentioning is by design, this is data plane access, so the ability to sort of do the administrative or control plane functions against the volumes, but actually writing or accessing the data within the volumes is done so through NAS protocols.
I think this is a conscious decision from a security perspective. We spoke to enterprise customers, two things. We want to always make sure your volumes get an IP address from your VNet, not publicly accessible. And it can be mounted through standard NAS protocols. We thought about it. We didn't want to be able to somebody to read data using a REST API or control plane operation.
So another spin at this, building this up through different layers. So one is these are fully managed bare metal systems. So I think one question that we get, or one thing people don't know, so again, if you sort of only remember a few things that stick, these are actually bare metal NetApp systems that are hosted inside an Azure data center. It's not a virtual appliance or a virtual instance. These are actual ONTAP FAS clusters, right? And this fleet is built for high availability and durability and for scale. So, the lowest atomic unit we think about as sort of we're managing these resources is already in of itself like a full NetApp cluster, right? Which in of itself is a highly redundant and resilient entity, right? You can have node failures, but still maintain availability and also performance and access to the data. And a single cluster is sort of just one atomic unit we use, but we're building a fleet out of multiple clusters, so a cluster of clusters, if you will. And it's fully managed. So again, besides anything that isn't autonomously done by the service delivery layer, as part of the service, we fully manage that. That includes lifecycle things. So of course, there's the bring up and build out. But at the end of life, how many people like doing end of life migrations, upgrades, head swaps, or firmware updates, ONTAP updates? All of that is taken care of autonomously as part of the service. And then in terms of like capacity management, right? As Prashant said, you get your volumes, you consume them, logical capacity, you take snapshots, it's incremental, it's very straightforward. Had a customer talking to me yesterday, it's like, oh, what about the waffle reserve and all of that? Nope, you don't have to worry about any of that stuff. You don't have to worry about how your aggregates are laid out. You will get storage that is to the QoS that you can consume, and all of the rest of that in the background is fully managed, right? So it's meant to be very turnkey. It's just consumable as a service, right? And again, high availability. You get the cluster node redundancy, and then we have additional layers of redundancy that we can deploy across stamps, right? So I can migrate tenants for load or performance balancing or capacity management, or for lifecycle types of functions.
It includes integration with the Azure network. No single point of failure.
Yep. So actually, so actually, that's true. Everything is built multi-redundant. And then the next core thing is that this is very natively, or the way I'll colloquially put it, is hot-wired into the Azure network. So if you've worked with other sort of forms of, there have been a lot of attempts to deploy, on-premise or bare metal storage appliances close to cloud that include things like using WAN technologies like ExpressRoute or whatnot. This is not that with a pretty portal experience or a skin. We've done some new technology and some very different things. This is physically placed inside of the data center, so latency, across the location, like from an outside location into the data center, is not an issue. And two, this is directly wired into our software-defined network, right? So we have enough bandwidth and capacity from a networking standpoint to fully utilize all of the available throughput of the cluster and do so at low latency, right? So we have no practical bandwidth constraint in the infrastructure, right? And you can see the latency, you can see the performance benefits from the teaser that Prashant showed you. But again, this is sort of a no compromises implementation for how this thing is connected. But also, because of the automation we've done, it's a very fast and easy deployment experience, right? So again, versus, okay, do I have to work with my colo or my exchange provider or my telco, and do I have to get, like a dedicated WAN circuit and all of that? No, you can go from zero to mounting your volumes, fully turnkey in a matter of minutes, and you do so interacting with sort of very familiar Azure transactions, objects, and concepts. And then finally, secure tenancy and dedicated tenancy, both from sort of your storage and from the networking perspective, right? So we've combined multi-tenant technologies both from Azure and also things that NetApp has innovated and invested in over decades to make sure that your tenancy is fully secure, right? So at the storage level, you have a dedicated storage virtual machine. It's completely isolated. You're also assigned the logical interface, and also a separate IP space, so there's no sort of collision or interaction of network traffic between you and other tenants. And the same thing happens all the way through and through up the stack until that data securely enters your VNet. So you're assigned, separate, dedicated, and segregated VLANs, and all of the traffic, again, is autonomously kept separate and routed through the entire experience. And then data protection, right? So as Prashant mentioned, but I think hopefully everyone knows, the golden rule of storage: never lose the data, right? That's like rule 1, 2, and 3. It's like location in real estate. So multiple layers of redundancy there, right? So aside from the cluster level redundancy, multi-parity redundancy on the drives or the flash drives. So of course we can survive multi-device failures. We have the appropriate hot spares provisioned in place, all to the best practice to make sure that your data is protected from that standpoint. Data at rest encryption, so all data written to media, is written using the FIPS 140-2 compliant data encryption that Prashant mentioned. Today, that encryption is done with service-managed keys, so we handle that. And again, all the media, everything that's written on media is encrypted. But watch this space. In the future, we will be progressively delivering more options for customers to manage or have greater control over the keys that they're using to encrypt the data. And then finally, the other layer of protection, again, referring back to yesterday's talk where they talked about this, disk drive chipper that we have in all of our data centers. And I've personally seen it, and it's pretty horrifying being someone who worked in the disk drive industry for over a decade. You literally put in a disk and this pile of like silvery dust comes out of it, and that same chipper is used on devices here. So any failed data-bearing device never leaves an Azure data center, right? So, even if we didn't have the encryption in place, which we do, no device that's bearing any bits from your tenancy will ever leave the four walls of an Azure data center, right? And then at a logical level, additional levels of protection, right? So you have the checksum on landing to make sure that there's no data corruption or missed bits in the write, and then ongoing background scrubbing and integrity checking to make sure there's no silent data corruption, bit rot, or anything happening to your data over its entire life cycle. So fully end-to-end built for bare metal, best practices to be deployed for your consumption. So how does this work from a networking standpoint? If you have a little, academic curiosity in terms of what was done, it's an emerging pattern that we have in the networking space, Azure networking, called service VNet injection. And there's sort of actually two patterns to this, which is one, the ability to take a managed bare metal service and deploy that securely inside your VNet. There's also a variant of this that's a feature if you're using other Azure storage services, particularly ones with public endpoints like Azure Blobs. That's also emerging, where you'll then be able to have that be only routed from your VNet versus publicly accessible. So there's some documentation there if you have sort of more interest in this topic. But basically, if you deploy this service, part of the experience that we'll show you is you will create a delegated subnet within the VNet in which you intend to use these. And that subnet basically does a couple things. One, it allows you to define an IP range, and that's based on feedback we got from customers in the preview, which is like, hey, how do I know where volumes and mounts are going to just sort of start popping up, right? I have other things going on that VNet, or I probably have some policy or some process around how I control the IP address ranges there. So the delegated subnet gives you control over how much of the IP range you want to be able to assign and give to the service. And then once you've done that, the service has sort of latitude to autonomously deploy the resources that it needs to make the storage available to you. And so then what happens is when you create your first volume, it will actually deploy a NIC inside of that subnet, which is sort of an object or a representation of the IP address that it's using or securing, through which it will present volumes, right? And as you create volumes and you have mount points, the mount point, of course, is a combination of the file path that you specify plus the IP address. So you can sort of see then I've got a NIC, I've got a volume that's presented through that, and now I'm ready to mount that through VMs or whatever resources want to use that storage inside of my VNet. A couple key important factors to consider around this. The NIC is sort of more of a logical abstraction that represents the IP address, but it is orthogonal from throughput or the bandwidth that you'll see against that. So there's not a need to then start thinking about like, oh, should I do multiple subnets, or should I try and stripe wide across many NICs to get more throughput? Your throughput, again, is a function of two things: the quota that you've assigned the volume, which defines the capacity, and the service level, which is the baseline of how much throughput you get on a per capacity basis. If it's necessary to assign more IP addresses because of some scale limit or to deliver performance, the service will autonomously do that. But it will be very common for multiple volumes to be served from a single NIC, and that's not something that's compromising your performance experience or consumption of the service in any other way. So then you also don't worry like, oh my gosh, well, if I have hundreds of volumes that I'm thinking about using, how wide of an IP range or how many of these addresses do I have to give up? It will be a many-to-one relationship, and that is by design.
Yeah, I think just maybe obvious, just emphasizing as in the pointer Andrew has here, that's complex, the implementation is complex, but we're doing the heavy lifting for you. You as a user, all you have to do is, as Andrew said, identify a subnet, delegate it to Azure NetApp Files. We'll pick up the IP address as we create volumes, and we'll use. You do not have to worry about any of it. So any of your end users, data scientists, people who they don't have to understand storage or networking. All they do is create volumes and mount it. Nothing else matters for them.
So a couple key things. We are still in preview, so we haven't broadly and publicly disclosed the pricing around the service, so we'll ask that you bear with us there. But in terms of some of the principles, one of the things I wanted to outline is that we want it to be predictable and easy to consume. So the basis for the cost of the storage will be just basically straight pennies or dollars per gig per month. And as Prashant said, prorated on the time of consumption, right? And then charged against your provisioned capacity. So what that means is there won't be a transaction or like an egress charge for just basic writes or interaction with this, right? We want you to be able to move your most critical and demanding workloads into Azure, and interact with them heavily with resources, right? Like our ideal case, and which is why we built this to be exercised so aggressively, is that you have some very mission critical, very high throughput workload that's exercising against the storage. So again, it's a function of what what service level tier you picked, how much capacity you've deployed, and then you will get a predictable cost from a storage standpoint. And the way the service level works is it's basically you can use as much or as little as you like up to the QoS. So we don't have like a credit or a bursting system. Basically, you can take it up all the way to the limit and run it there if you like. Although hopefully you don't, but or please buy the extreme. But it's meant to be very predictable. And then of course everything else that's ancillary related to that in Azure that you're consuming is per typical charges. And then some sort of factors or things to consider around deploying and using the service. So to build a little bit on some of the concepts we covered, right? So you have this VNet, you've deployed Azure NetApp Files in it. What else can you do with it? So if you peer that VNet with another VNet within the region, then the volume is accessible, so you can access it from multiple VNets. The VNet has to be joined either through within region peering or over a VPN gateway. One bit of fine print is at this exact time. If you're using the relatively newer cross-region VNet peering capability, we don't yet have the access, the ability to sort of route the traffic over that as of yet, but that's something we're working on to come in the future. And then also, if you have sort of hybrid scenarios, you're looking to move data from on-prem, if you connect ExpressRoute and deploy an ExpressRoute gateway within that VNet, then you could also push data into that VNet, into the Azure NetApp volumes through that as well. And then one other thing is there are some unique elements of that delegated subnet and the associated NIC. That NIC is pretty much completely under the control of the service, and so we don't allow you to do things like destroy it. If you delete your tenancy, then as part of the cleanup, the NIC will be removed. But of course, we wouldn't want you deleting that NIC and then sort of stranding the volumes or all of your access to that. One other thing is you also cannot at this time yet apply network security groups against that NIC. That's something that we will probably support at some point in the future. But in the meantime, if you need network ACLs or the ability to sort of restrict or control access to the volume based on network attributes, that can be done through export policies, which we'll illustrate in a little bit.
Maybe this question comes often, so I'll just re-summarize. Simple takeaway. Can I mount, clearly you can mount the volume in your VNet on any VM you would want to. Can I mount an ANF volume in a different VNet in the same region? Answer is yes, you can use VNet peering. Question is, can I mount the volume on a different VM in a VNet in a different region? Well, the answer is yes, if you use a VPN gateway, you can't use VNet peering there. So that's really the key takeaway.
Okay, so I've been talking a lot, going through a lot of charts, so thanks for bearing with. Why don't we actually do, show what the actual portal experience looks like. So you can see here, I've pinned it, but if you go to the marketplace, or you just sort of go to the general search and you look at NetApp, you'll be able to see. And again, right now this is in preview, so it's not publicly available. This is once you've been whitelisted and onboarded in the preview. But you could just go ahead, search this, and do a create experience, pretty much same as again any other Azure service. So here we're creating the NetApp account. Again, it's kind of a parallel construct, but a different namespace from sort of our other storage accounts. You name it, you pick your subscription, you can put it in a resource group. Again, same as anything else. You'd pick your region and then you hit go, and then it'll create the account. And this one takes a little while because again, it's now securing a tenancy and doing some of the administrative work on the cluster. It's picking the cluster and figuring out where it goes. So again, all of those administrative tasks, all of that automation that I talked about is currently happening right now. And so we'll just sort of wait for the paint to dry for a few moments here, and then we'll get a message that the account has successfully deployed. Oh, and there it is. So now if you go into the account, and you can see here again, you get the same notifications. You can pin the tile to the dashboard, and you go in. There it is. And like I said, if you want to do RBAC against the administrative functions, you can assign roles, same as anything else. And then now go to capacity pools and add a pool. So again, you have to name it. And then there, again, right now in our preview, we only have the premium, but if you want, you could pick a different SLA once we have the additional ones available and choose that, and then choose the provision size. And then away you go and create the capacity pool. So that's sort of that next level in our hierarchy that we explained. And then now if you go to the pool, it's there. You can see here that it has, properties, it has IDs, resources IDs, subscription, again, everything very same as Azure. And then now you can create volumes, because right now our pool is empty, so let's make a volume to consume against it. You can see here it wants a volume name, file path name, which pool it's going to draw against, right? And then it'll show how much quota is remaining or has not yet been consumed or assigned against that pool. You can pick how much quota then you want to give that volume, and remember that's also going to set the gross throughput that's available to that based on the QoS and the tier you picked. Then you pick which virtual network this is going to go into, and then you need to basically put that inside the delegated subnet, as I mentioned, and then hit create. And then it's going to go through the final steps of creating a volume, setting that policy, wiring it up, and popping it into the VNet. So we'll see that workflow complete shortly. Sorry, I don't know any good jokes, or I would do something, but
One thing we didn't cover in this demo is, you saw in the volume create, there was already a delegated subnet there.
yeah.
It's already in the dropdown. You have to go into the VNet subnet blade, and that's where you create a subnet and say, I'm delegating it to Azure NetApp Files. So that's one step you have to do outside of.
Yeah, and we'll actually show that, and then in the future it'll actually be doable in situ from this blade.
Yes, in the future.
We don't have it yet.
But for now, anytime in the preview, you'd have to go create the subnet, delegate it, and then you pick from the dropdown in the volume create.
Let's see, do I even have enough time? Oh, no, don't even have time to get a drink. And so there it is. I think from when we started this till now in the span of about 3 minutes real time, absolute zero to a volume that's ready to go, right? And you can see there's a blade here where they have mount instructions. But let's go back. I want to kind of review the resources, so everything that's appeared in this resource group. And you can see hierarchically, right, you have the account, you have the pool, and you have the volume. So all of those are sort of objects you can, click on and directly take you there and interact with them. And there with the sort of incomprehensible hash name is also that nick that I promised you. And then if you look at the VNet, you can see here within the subnets, and we had sort of pre-provisioned this, there is that delegated subnet. And at the bottom, there is the option to say, okay, I want to delegate this to a service, and it's the Microsoft.NetApp/volumes service. So that's basically how we had sort of pre-done that. If you go back to the volumes, let's see, a couple of things is, one, there's a very handy blade here with basically, I think it's literally 4 clicks, 2 copies and 2 pastes. You can just put this in your VM, and your volume is attached, mounted, and ready to begin serving storage. And we'll spend a little bit more time on this in the next walkthrough, but you can see here are the blades for export policy and also snapshots. So,
one question we get asked about, well, how large of a delegated subnet should I create? And as Andrew mentioned, the mapping is many to one. For customers who expect less than 100 volumes, 8 or less addresses should be more than enough. But in the case, let's say you forecast 100 volumes, and then in the your growth is beyond your forecast, and you run out of delegated subnet space, you can come back and create another delegated subnet, and you can assign it to the service. So it's you can always add more delegated subnets to the service.
yeah.
It's not a problem you should be worried about. Going on to talking about networking, and we talked about how important we thought it was to grab an IP address for the mount point from your VNet and give you the choice. We thought it's fundamental to security. The other controls beyond that is export policies. If you use ONTAP, you're aware of it. At a volume granular level, you can go and assign 5 rules per volume, and you can control which clients within your VNet, clients or subnet range, can access, what kind of access they can have, and also choose the protocol. As we enable multi-protocol on this service, you will have a choice of not just versions, but also other protocols you can control. So that's the intent of export policies. It's not a replacement for network security groups. It's something ONTAP has. We are using it now, and in the future, we'll also have NSGs on our delegated subnets. Sticking on to security, we talked about data at rest encryption using FIPS-compliant implementation. We talked about export policies. We talked about multi-tenancy. There are a lot of other, and then of course we talked about ARM architecture and how it's secure, the control planes resting behind all the things Azure platform has. But there's also a lot of other goodness ONTAP has delivered for enterprise customers to get security at scale, right? You don't want to be using local UIDs and GUIDs. A lot of enterprise customers use a database, AD or LDAP, where all the permissions are there. We'll be enabling those enhanced or those capabilities that are already baked into ONTAP in this service. Using LDAP, for example, with NFS, Kerberos, Kerberos Phi, and Kerberos Phi-P. So you can get not only authentication, but your data on wire, NFS data, can be encrypted right from the client. Same applies for multi-protocol. Similar in SMB, you heard about sealing and signaling. Same capabilities will be enabled going forward. And then, as Andrew had mentioned earlier, we talked about keys currently are managed by NetApp and Microsoft. ONTAP already has enhancements where you can store the keys off box on a KMIP compliant server, a key management server. So those are some capabilities we'll be enabling in the future to ensure there is no, security is front and central for us.
Absolutely.
For many of you, your storage background, you understand the way snapshots work in ONTAP. The slide really goes through one-on-one of how ONTAP snapshots work. It's a simple illustration of the pointer and metadata magic that Waffle uses to ensure you can get extremely fast snapshots which have no impact on performance. You can get instant restores, and making it the foundational technology for things like flex clones. So this example really starts out by showing if you have a volume and you've written some data to it, let's assume it maps to 3 blocks on file, A, B, and C. In the active file system space, Waffle's really carrying some metadata and pointers to those blocks. And then as you take a snapshot, the snapshot 1 only has pointers to the same block. You're not creating a copy. You don't have 2 copies of your data. As you write to it, and let's say you change block B, and there is block B1, Waffle's going to go and create a new block B1 to it because the snap is referring to it. At this point, on the physical block level, you have 4 blocks. You have 2 actual copies. You're not paying for 2 full copies. Same thing plays out. You can go and create a snap 2. They're all pointers. So net, now you have 3 copies that are created, and you're not paying for 3. You're just paying for 1 copy plus some incremental. And all of these snaps are instant, no performance hit. You can restore it to the same volume or a new volume. And the ONTAP ecosystem, the NetApp ecosystem, extends these benefits to applications. So if you have Oracle or SQL Server or SAP HANA, you can take application consistent snapshots. That's a huge capability, right? You just don't want random snapshots. You want snapshots which are consistent with your application so you can roll back. And as we mentioned earlier, the snaps are a foundational technology which will be used for clones. If you want a clone, you can say, well, I use a latest snapshot, snapshot 3. I'm going to use this to create a clone, and immediately you get a read-writable clone. You can create hundreds of those clones instantaneously and then pass it on to your analytics team, DevOps team, all of it without any performance hit. And of course, you're paying nothing for it, really.
And to the first order, mostly independent of the size of the data being snapped and cloned.
Correct. That's huge. You can have a 100 terabyte volume, and you can create multiple snaps and clones instantaneously. It's irrespective of the size of your data. Some limits to remember. This is on tap.
Yeah, Andrew can't type, so it's 255.
Local snapshots, 255. Yep. That's really it, as in.
So we'll do one more walkthrough and show, okay, now what happens when you actually interact with the volume. And this is sort of within the limits of Andrew's own ability here. But again, like I said, with literally 2 copies and 2 pastes, you can mount the volume, access it, and be off and running. So then, if we, we'll sort of elevate the permissions to make it easy, and then go into the directory here inside the mounted volume, And then you can see here, right there, there's the .snapshot directory, kind of one of the signature, for those who are familiar and have interacted with NetApp, there it is. And we'll just throw a sample file in there and do a quick illustration. So, of course, because I have no imagination at all, what am I going to say? Hello world. I didn't have time to do ASCII art like one of our other folks does. It's like the coolest thing, and I'm just not that clever. So you can see here we have our text file. So just a really simple illustration there. And there it is in my directory. So now if I go back to the portal experience, go to the snapshot blade, and then at least from the portal, it's one click, right? Add a snapshot, give it a name, and let her rip. And again, the snapshots are extremely fast because all it's really doing is pointer magic. So you know, this was a 100 gig volume, but if I did this on a terabyte volume or if I did this on a multi-terabyte volume, pretty much works the same. So now if I go into the snapshot directory, you can see there's the snapshot that I took. That was basically instantaneous. And then if I go into that, there's my little cheesy hello world file in snapshot. And then of course, if I were to delete it from the active file system, you could still see it. So just a very simple illustration of a snapshot, you know, performantly and instantly at work. And then from there, you can see if I want to, so a couple things is, let's see, what was I doing here? One is the ability to restore to a new volume, right? So this is currently how we've implemented a variant of the cloning, but basically you just give it the name, you give it the same coordinates, and it would instantly hydrate that snapshot into a brand new volume ready for use. And you can see here one of the other key properties is the export policy blade, where you can set those network ACLs that Prashant mentioned. So that's the walkthrough there. And then I'll turn it over for, I think, our last topic of this section, which is how do you get data into Azure NetApp Files, at least today.
Right? We've been asked, like, wow, you have a great service. How do I move my data into Azure NetApp Files? Lots of ways. Simple, easy is Cloud Sync. It's a NetApp service. You can go to cloud.netapp.com and try it out for free. What it is, it's a simple, easy, managed way to move data in and out from on-prem to any file share in the cloud, Azure NetApp Files. You had customers, depending on the size of your pipe, you had customers move as much as 30 to 40 terabytes in a single day from on-prem to the cloud. And in aggregate, they've been able to move petabytes of data. So it's a great service, and in this, you know, we had a recorded demo. We didn't have time, but we were showing how you could move data from Amazon EFS to Azure NetApp Files, all using Cloud Sync. You could do it from Amazon. You could do it from on-prem. It's a great tool, and you can also use it to copy data between regions in Azure. You can create a volume, ANF volume in region 2 in a different VNet, and use Cloud Sync to create a copy.
Yep. So I'm sure as fantastic as both Prashant and I are, be good to get a fresh face on stage. So it's my pleasure to invite Kent Christensen to join us up here. Kent is with Insight Data Link, and it's a valued partner, both a very long-time partner of NetApp, but also a valued partner for us in Azure, and doing some really interesting things together. You know, both now with Azure NetApp Files. He's been with us since early on in the preview journey, as well as some of our other cloud initiatives. So, Kent, if you could please.
Yeah, no, we absolutely appreciate the partnership, and yes, we have been talking about this for a while. We've always had a deep roadmap relationship with NetApp, and so, you know, way back when, it was most intuitive to us for this is an extension of what NetApp has been calling the data fabric, which is their vision that says we're going to be the data management platform, whether you're on-prem, in a hybrid environment, in the cloud. So we've been working with kind of the early data fabric products, Cloud ONTAP, MPS, which is putting ONTAP next to the cloud in like an Equinix data center, et cetera. So this was, you know, a great extension of that. We have found as we've started, you know, we did the testing in the private preview starting last year. We're doing the public preview right now. You can see how simple it is. Sometimes it's almost too simple. Actually, in the last session, we had a client come up and say, okay, you know, you guys are working with me in multi-data centers, et cetera. And what we find is they're kind of looking at their evolving cloud strategies. And like, well, how does this work for DR? How does this work for that, et cetera? And sometimes it's so simple that they want to put everything there, and it's not appropriate for everything. And so we actually created a service.
But yeah.
We actually created a service where we'll help understand your data and your usage and things like that. We collect information with tools and help build a roadmap of where you put those things across those different solutions. Now that concept of finding workloads and finding the appropriate portion of cloud or on-prem or hybrid is something in a broader context we do with all kinds of workloads, all the client applications. So that's pretty common for us to do, you know, a workload alignment, et cetera. And we find, you know, as we're looking at workloads and people want to get, you know, X amount of stuff into the cloud, you know, some of those mission critical workloads that are maybe running on Linux, that was a challenge, right? I'd have to refactor, I'd have to do this, or I'd have to do this, or I'd have to give something up. So obviously this is a great service, very, very high performance for those Linux workloads, et cetera. We also find as we start moving further away from IT, you know, the real client where we were working with them on one of the earlier cases of the data fabric, if you would. They were doing genomics processing, and they were doing it all in one cloud provider, and they were having certain challenges with consistency and performance and things that this service will start to resolve. So we built a solution that was one of those next to the cloud solutions, and they got a much more consistent outcome leveraging the NetApp. They didn't even know it was NetApp. They were just trying to do genomics processing, and we just gave them a better cloud storage version, et cetera. So they were getting 10x the performance, which is what we're seeing here, is 10x the performance of some of the stuff that's currently available on cloud providers. As they started thinking about how to consume it, they said, okay, well, if I build it in that kind of MPS hosted environment, then I'm going to build a certain size sandbox, and I'll be able to use that sandbox. If I leverage a service like this, then I can go and have the data scientists basically say, whatever you want to spin up and down, go at it, right? I'm not going to limit you by provisioning infrastructure and things like that. Again, these guys can take advantage of that. So they are now, even though they have the service, they have all the performance, they're very happy, they're like, okay, we got to test Azure NetApp Files because that might give us the flexibility to really expand that. And further, moving even further away from IT, we have a division of Insight, so DataLink Insight. DataLink was acquired by Insight. There's a bunch of divisions of Insight. We're one of them. We're the Cloud and Data Center Transformation. We have another division called Digital Innovation, or some people at Microsoft know them as Blue Metal, which is also just recently announced that it's Microsoft's AI Partner of the Year. So one of the things we've been talking about is, you know, those guys would look at an NFS service and say that's for those guys that they consider IT people, kind of a lower life form. That's an IT thing that we add value to the clients. So we started talking about, well, we can make this an HDFS service. We can use HD Insights. Now they're leaning forward. So as maybe the next time we're in public discussions with this might be at the NetApp Insight Conference, and we're planning on having that be a live demo of them doing AI, deep text learning, and things like that, leveraging this service, because they're pretty excited about the opportunity and the possibilities. So thank you.
Awesome. Thanks so much, Ken.
Thank you.
Appreciate it. In closing, a couple things is we do have a blog post that announced our preview, and we do have a landing page on azure.com. So if you go there, you can get documentation, you can get more information. You can register for the preview, or you can read up. Of course, as we get further and further into the conference, the number of related sessions, sorry, let me back that up. I'm more than happy to have folks take pictures of it. The number of related sessions still to go continues to dwindle. Actually, now these are both recordings, but there were some really great recordings, sessions on data migration and also data protection, backup and DR. So encourage you to check those out. We'll also be here for any Q&A. And then last, of course, is please do fill out the evaluations. And with that, we'll turn it over for Q&A. But if we don't get a chance to, thank you very much for your time, and hopefully looking forward to working with all of you on getting your ANF journey going. So thank you. Yes, and in case you don't have any after-hours plans, we do have an Azure Storage Mixer event going down in 208 right now. So feel free to pop down there and get some drinks as well. So from now till 6, and I think we pretty much just sent everybody heading for the doors with that one. But if anyone has any questions, we'll be here as well. So thank you so much.